This video will go over how to graph logarithmic functions. Okay, so there are a couple ways to do this. One way is to just plug in numbers in for x and then get your y values. However, being that this is a log function, that could be a little bit tricky, so let me show you what I mean. So let's pretend we picked the number 1 for x. Okay, so if we plug in 1 for x, this is asking us 3 to what power is 1? So 3 to what power would get us 1? And that would be 0. So that was no problem. But let's say I pick the number 2 to plug in for x. So if I plug in the number 2, 3 to what power is 2? That would be a little bit more tricky, and then most would probably cross that out and pick a different number, and keep picking numbers until they're ones that you could do without a calculator. They won't be decimals. So picking numbers for x, certainly you can go about it that way. Remember, you can't have negatives for x. So you want to, if you're going to pick numbers for x, think about the domain. So this is saying 3 to what power will get you that x value, and this can never be a negative, so you don't want to pick any negatives here. Okay, so you always want to consider the domain. Now I have some steps here, and this is how I prefer to do it. Since a log can be changed into a exponential, that's how I prefer to do it. Just like you could change a fraction to a decimal, right? It has a different version of it. So the first step that I would do is, instead of graphing logs, I would, since we just talked about in the last video how to graph exponentials, I'm going to choose to convert the equation to an exponential function, and we'll talk about why I choose to do that in a moment. Okay, now f of x is the same thing as y, so I can put a y there. It just represents the output. Okay, so I'm going to go ahead and convert this, and remember we learned the circle thing. So this is saying 3 to the y would get me x. Okay, so that's step 1. Convert it to the exponential form. So again, this is saying 3 to what power gets me x? Well, we're using y for the exponent. Okay, so then step 2, instead of plugging numbers like we normally do in for x, instead we're going to plug numbers in for y, because we can do that much easier. We could put numbers in this spot here and do 3 squared or 3 cubed a lot easier than having to plug in numbers for x. So I'm going to go ahead and substitute values for y and then get the x. So instead of picking numbers here, I'm going to pick numbers here. And any number can go into the y spot here because it's just an exponent. So I could pick -1, -2, 1, 2. Okay, we could pick whatever number we want, and then we would plug them in. So I'm going to plug in -1. So 3 to the negative first power is 1/3. So we're going backwards. Okay, so we get 1/3. And then we're going to plug in -2. So here we're going to instead plug in a -2. So 3 to the negative second power is 1/9. So we get 1/9. Then we're going to go ahead and plug in +1. So in the y spot we'll plug in 1 to get x, and we would get 3 to the first is just 3. And then we're going to plug in 2 for y. So 3 squared is 9. Okay, so a little bit different than what we're used to, because we're used to picking numbers in for x, but instead we're plugging it in for y, so that way we can just evaluate this. So then we're going to go ahead and graph these points. So we have 1, 0, and then we have 1/3, so just a little bit over, and -1. Okay, then we have 1/9, so a little bit less, and -2. And then we have 3, 1, and then 9, 2. Okay, so after we've plotted our points, we need to use, since this is the first time that we've graphed a logarithm, we want to use a graphing calculator to see more points. So if we take a look here, we can see that it's going to go infinitely. It keeps going and going and going in that kind of curved shape there. And then here, it never passes on this side. It gets closer, so close it looks like it's on the y-axis, but it's not. So it keeps going and going and going. So when we connect these points, we're going to make this keep going and going that way, and then this will never cross the y-axis. So you could draw a vertical line here, and it's dashed, so it's not really there, to remind yourself like it will never cross into that area. So no, it will never go over here. So this is very similar to our last section of notes when we were graphing exponentials, in that when you're graphing exponentials, so here's from the last 10.3, you could see when you're graphing the exponential, because the x is in the exponent spot, whereas here it is the y once we've converted it. That's why they look, this one's going to never cross the x-axis, whereas this one's never going to cross the y-axis, because the x's and the y's are swapped, and so they are inverses. Okay. So now the domain here, we go left to right on the graph. So if we look here, it's going to approach, and remember domain is the x's, so the x value, so x is 0 right here. So it goes from 0, but we're going to use a parenthesis because it never is going to actually touch 0. And then it goes infinitely to the right side. Now the range is from the bottom to the top. So at the bottom, it's going infinitely in the negative. And then as we go to the top, it keeps going up and up and up. So again, if we compare this to our notes from 10.3, we can see that here they are inverses. It's swapped. So the x and the y are swapped, and we could see how they would reflect over the line y equals x here. Okay, so let's go ahead and try and graph another one here. So I do also want to point out before we move on to the next one, you can see that the base here is 3, okay? And remember what we learned in 10.3, when the base is greater than 1, it represents growth from the left to the right. So from the left to the right, it's going upward, so it's the same rules apply because the base is greater than 1. So if we take a look at the next one we're going to graph here, the base is in between 0 and 1. So 1/3 is in between 0 and 1. So this should represent decay. So again, you can go ahead and plug in whatever numbers you want for x, or we can convert this. So f of x, we can put y in its place. And then this is saying 1/3 to what power is x? Well, we're going to use y, right? So in other words, we make the circle thing. That's how we convert it to an exponential. Now, instead of picking x's, since there's a y right here, we're going to pick our y values. So I'm going to go ahead and pick -1, I'm going to pick -2, -1, 0, 1, and 2. Those are the numbers I'm going to pick. And then we're going to go ahead and plug them in. So 1/3 raised to the negative second power. So a negative exponent will flip it, and then 3 times 3 is 9. So we would get 9. Then I'm going to go ahead and plug in -1 for x, or I'm sorry, for y. So then it's going to flip it, and we would just get 3. And then I'm going to plug in 0, so 1/3 to the 0 power. Anything to the 0 power is 1. Then I'm going to plug in +1, and 1/3 to the first power is just 1/3. And then 1/3 squared is 1/3 times 1/3, which is 1/9. Okay, so now we're going to go ahead and graph these points. So 9, -2, 3, -1, 1, 0, 1/3 1, and then 1/9 2. So this time it's going to keep going over here. And then here it's going to get closer and closer and closer, just like the last problem, but it's never going to cross over the y-axis. So again, if you want to, you can draw this vertical dashed line to show it's never going to cross over that. So then our domain from the left to the right, it's getting closer and closer. Again, it's the x-axis we're looking at, left to right. It's going to start at 0 but never touch it, and then the x values are going to keep going and going and going to the right. The range is from the bottom to the top. So at the bottom it's going infinitely down, and as we go to the top it keeps going up. Okay. So when the base is greater than 1, so here it wasn't, when it's greater than 1, like it was here, when the base is greater than 1, it's going to grow. It's going to represent that the logarithmic function is increasing. And again, we always do that from left to right. And when the base is in between 0 and 1, the logarithmic function is decreasing. From again left to right. There is no y-intercept. The graph gets very close to the y-axis but never touches it. So again, this applies to the parent function. So again, what that means is, like if I have log base b and then a number here, it means that I don't have any numbers besides the base, so like a 3 here. So things will change, and there will be transformations if, let's say, I go and put a -1 here with the x, or if I go put a number in the front, things will change. So we are just talking about in this class if we just have something more simple like this, where we don't have numbers with the x and in front and flipping things and all of that kind of stuff. Okay, so again, to recap, when you're graphing a logarithm, my advice is to convert it to an exponential function and plug your numbers in for the y's. And again, as we saw that a log and an exponential function, they have inverses. We learned about that in section 10.2, what inverses are, because their x's and their y's are all switched.